The Lambda Way Project is a web application built on two engines. Lambda Tank, a tiny wiki built as a thin overlay on top of any web browser. Lambda Talk, a purely functional language, unifying authoring, styling, and scripting in a single and coherent expression-based syntax. In this presentation, we forget Lambda Tank, mainly a PHP engine managing text files on the server side, and progressively introduce Lambda Talk, a JavaScript engine evaluating code in real time on the client side. The making of Lambda Talk is progressively described in 3 steps. Oui.
If this is a page, can you zoom in just a little bit so you can see it better in the back?
And I don't understand the question.
Can you just blow up the text a little bit?
Oh, yeah, okay.
Sorry.
Comme ça? Better? So, the making of Lambda Talk is progressively described in 3 steps. Lambda Word, built on a minimal set of 3 rules. Lambda Calc, and ends with numbers and operators, and Lambda Talk on top of browser's functionalities. As a guiding line, we give for each step a recursive algorithm computing the factorial of any natural number with all valid digits. Lambda Word. Lambda Word is freely inspired by the Lambda calculus. A Lambda Word expression is made of words, abstractions, and applications. A word is any character except spaces and curly braces, and is not evaluated out of curly braces. An abstraction is a special form called a function, selecting words called arguments in an expression called body, and is evaluated to a word referencing an anonymous function added to a single dictionary. An application is a simple form calling an abstraction to replace selected words by some other words called values, and is evaluated to words. And the evaluation stops when all expressions have been replaced by words. What can be done with so little? In order to make code easier to write and read, we add a second special form. It's not mandatory, but it's better. Def word expression, allowing to create constants added to the dictionary and give names to anonymous functions. In this example, you see that out of curly braces, words are not evaluated. Hello world, hello world. Sequences of words can be given a name here. This abstraction defines O and A as words whose occurrences in the expression "How happy day" will be replaced by some other words and returns the reference to an anonymous function. Here the abstraction is defined and immediately called.
How does this work with the Lambda OA and you have 3 words and you have 2 parameters?
I'm sorry, I am not fluent in English. I will answer your question a little later.
Okay.
Thank you very much. The abstraction is first evaluated. The application gets the awaited values, called the abstraction, which makes the substitution and returns the result. Abstractions can be given a name and then called easily several times. Most of the time, expressions are nested. The expression below returns the first and the second word of a hello word. Using names helps to recognize the data structure and its accessors. The unreadable expression below is evaluated to an anonymous function. We will demonstrate later that this expression evaluates to the factorial of 5. Implementation. Lambda Talk is not implemented following the standard process code tokens tree eval. The code is a string from beginning to end. At each keyboard input, the code is processed by a single function do eval, which returns words sent to the browser for the final evaluation and display. The eval lambdas and eval def functions match special forms, evaluate them to anonymous functions and constants, and add them to the dictionary, and replace them in the code string by words. Then the eval forms function progressively replaces nested forms by words. Evaluation of nested forms. Using a single regular expression, the eval form function loops over the code string, skips the words out of curly braces, matches nested form from inside out, and replaces them by words. The repeated substitutions inside the code string overcomes limitations of a regular language. The JavaScript implementation of the eval forms function is amazingly simple. One line of JavaScript, one regular expression. How do Lambda works? Lambdas use arguments as regular expressions to successively replace occurrences found in the function's body by the given values. Lambdas have the following properties. Lambdas are first-class functions. Lambdas are pure black boxes. They don't create closure, no free variables, no lexical scoping. Lambdas accept de facto partial function application. A call with a number of values lesser than its arity, a lambda memorizes the given values and returns a new lambda waiting for the rest. Conclusion. To conclude this section, we remember that Lambda Word doesn't know anything but words, and it's difficult to believe that in example 1 to 3, we have computed the factorial of 5. It's time to give life to words. We leave Lambda Word and enter in Lambda Calc. Lambda Calc is Lambda Word plus numbers and operators. You know that after Alonso Church, we define a church number n as a function iterating in times the application of a function f on variable x. Apply to a couple of any words, church number, return strange things, inviting to define a function displaying them in a more familiar shape. Note that the church function is built on a primitive function and on numbers 0, 1, which are not supposed to exist at this point. Consider that it's only for readability. The definition of church numbers gives the basis of a set operators. The set successor, addition, multiplication power is rather easy to define. Classical. Building opposite operators like predecessor, subtraction, divide is not so easy, and Church himself avoided them in the primitive version of lambda calculus. The answer was given by Stephen called Clean for the favor of regular expressions. Church numbers can be used to iterate and pairs to aggregate. Applied to the pred operator, this sequence of transformations leads to define two functions pred pair, and you see the code here. We have no time to read more quickly. Control structure. The compact definition of the factorial here highlights the control structure, reminding the Conskar-Cadder data structure. The main difference is that the control structures must be evaluated lazily. Only one term must be evaluated, contrary to the data structure made of user-defined functions and evaluated eagerly. All terms are evaluated. Lambdas will help to introduce a touch of laziness. We sketch the body of the factorial, where the terms have been delayed thanks to lambda. We sketch the evaluation, and in the final form, we can write, thanks to lambdas and pairs, we could define a recursive process without any Boolean and any Y combinator. But we have to demonstrate that this code is equivalent to the unreadable expression shown in section 1 to 3, and the Y combinator will help us to do so. First, we replace the recursive function by an almost recursive one, on which we will apply an appropriate Y combinator. The Y combinator is here, very simple. We mix the both. Throwing away the name, we define and immediately call the lambda on the value 5. And finally, replacing all constants by their lambda-based values, we get the pure lambda calculus expression shown in section 1, 2, 3, not 5. Conclusion. Concluding this section, we have demonstrated that using nothing but the three initial rules, the factorial of any natural number can be computed theoretically without any limitation. But if computing the factorial of 5 is relatively fast, computing the factorial of 50 would still be too long, probably 1,000 years. Factorial of 10 out. It's time to remember that we can use the power of modern browsers to make coding easier and code much more effective. We leave Lambda Calc and enter in Lambda Talk. Lambda Talk is Lambda Word plus browsers full functionalities, some functionalities. In this section, we replace church numbers and their operators by the JavaScript mat object. We had built-in structures, pairs, lists, arrays. We had a new special form, if, bool, then, one, else, two, and some others. The set of special forms becomes lambda, def, if, let, quote, macro requires script style. LambdaTalk is now a functional programming language. There is no set bank special form for writing readable and effective code, beginning with recursive function. Just a look on the dictionary. Recursion made easy. Writing the basic version becomes straightforward. The tail recursive version too, but if it's now possible to compute the factorial of 50 in a decent time, 40 milliseconds, but the result is a rounded value with only 15 valid digits, we have to overcome limitations coming with the JavaScript math objects. So, the way the JavaScript math object is implemented puts the limit of natural numbers to 2 powers 54. Behind this limit, last digits are rounded to zeros, and behind 269, natural numbers are replaced by float numbers with maximum of 15 valid digits. In order to overcome this limitation, we remember that natural numbers can be defined as polynomials and implemented as lists. We present shortly two strategies. The first build on pure LambdaTalk code. We build and the second on calling an external JavaScript code. We build a set of pure LambdaTalk function working on natural big numbers defined as lists of digits here, on which we write a tail recursive version of the factorial, and theory becomes reality. We can actually compute the exact value of any natural number, but it's still very slow, about 10 seconds on a recent computer. Pure LambdaTalk functions are not the best choice for intensive computations. Plain JavaScript built-in function will help. Jonas Raoni Soares Silva has written a small and smart library, big number, ready to be called via LambdaTalk wrapping functions. We just extend the dictionary with a JavaScript function. It's JavaScript, no more LambdaTalk. We call it, in the syntax of LambdaTalk, the computation times decrease under 20 milliseconds. We can even compute bigger ones in a decent time. For instance, factorial of 500. Conclusion? We have presented the evolution of LambdaTalk from the foundations to the superstructures following the computation of the factorial of any natural number. Much more can be done. Writing math symbols, for instance, this is not a picture, it's math symbol without math ML, because math ML doesn't work in Chrome today, maybe. Sorting lists, traversing trees, creating spreadsheets. This is a spreadsheet with a language with LambdaTalk in the spreadsheet. It's possible to write. Okay. Creating PDF papers. For example, the paper submitted for this workshop was created using LambdaTalk, and this is the result. And JavaScript and LambdaTalk mixed to play with a lot of graphics. One last thing. A dwarf standing under their shoulders, LambdaTalk takes benefit from the extraordinary power of modern web browsers. It does not reinvent the wheel and simply adds a coherent and unique language on existing tools: HTML, CSS, DOM, JavaScript, PHP. The Lambda Way Project adds on browsers a thin overlay, LambdaTalk, proposing a small interactive development environment. You see the editor frame here, without any external dependencies, and thereby easy to download and install on any web account provider running PHP. From any web browser, on any system, complex and dynamic web pages can be created, enriched, structured, and tested in real time on the web. It's exactly how the current presentation was created at this address here. You can play on internet with these slides. Thank you.
Is there any decent performance out of the system? Because it seems like you've implemented all your primitives out of regular expressions.
Performance?
Est-ce qu'il y a la moindre performance du système. C'est pas du tout prévu pour faire de la performance ou est-ce que...
An answer is this one. Well, this page is computed in 39, 40, 50 milliseconds. Maybe it's an answer. You have seen just read that, so I will see every time all this. What you see here is what I write here. If I uncode the code, you see that 120, it works. Maybe it's no.
It's good enough for your regular performance, because I was expecting doing all this regular expression thing to be like slow as molasses, but that's fine.
How easy is it to escape to JavaScript? Si j'ai besoin de performance, est-ce que c'est facile de mélanger du JavaScript dans le Lambda Talk?
Yes, I did it.
Oh.
I did it here. At the end of the presentation.
Yes.
This presentation, all these things are I created with Lambda Talk in Lambda Talk, and here is
yes.
here
Yes.
in the lib. This first library is made of user-defined function in Lambda Talk, but it's too slow. And this one I can inline write. I can add, and it's very dangerous. But I can, I have no problem about security. It's not my problem, but it could be a real problem. So it's possible to add JavaScript to as a co-processor, a collaborator of Lambda Talk function.
Okay, and can you explain a little bit more the substitution model that you're using? So in the example that you had, lambda v of n, basically you added some words and then they exploded. Can you explain a little bit more how the word substitution is working?
Yes, maybe
a little bit higher, I think a little bit higher. Let's start with this example. Yeah, here, go down.
Do you have problems, say like alpha conversion or renaming, or how do you avoid the problems with...
I don't know why I avoid all these things, beta, alpha, eta, and so on. And I avoid the Boolean. I use the car cadre and cons structure. It's a data structure. Data structure is not good for a control structure because lazy, eager, and so on. But lambdas are here, and I can use them to introduce laziness. I was the first surprised to see that it was possible to, without the Y combinator, to write the code of a recursive function, which is relatively simple to understand, I think. And
my question wasn't that. I was asking about what's the substitution model. So if you go back into the lambda with the O and the A and the happy, right?
Yeah.
So you're right here, 1.22.
Easy, okay.
Okay, so you're writing lambda O of A, it takes two parameters, and you have three words in there, and there is no mention of the O and the A except that they appear.
The answer to your question is here. Here. Lambda, I think so. Use arguments as regular expression to successively replace occurrences found in the function, okay. But it's only string, so it's necessary to escape the arguments, and you can see here that I put a semicolon in front here, here, but not here. If I had put a semicolon on the A of day, I would have had day. To prevent the replacement, I must prefix, and it's not
the substitution and
okay. It's nothing but regular expression, And
you have to know that like people in this room here.
I know
like,
that
foreigns to regular expressions and.
I know that smart.
saying.
I know that smart people don't like think that regular expression can't pass nested forms. Yeah, they can't. Theoretically, but it's not only regular expression, it's a code very simple, but it exists. Where is it?
So crazy.
Well, ici. Voilà. You have a dictionary initially empty, only one line of JavaScript. The string is compared to the string after a replacement of the terminal, the inside form, first rest. This is the pattern, the regular expression, and here you recognize something standard, I think. If the name is belong to the dictionary, it is applied to the arguments and nothing more. And lambdas, something important is that it works because there are no closure. Don't create closure. There are context free. Inner lambdas don't see outer functions arguments, and it's a problem when I have to manually add the memory of the previous or the outer arguments. We can speak of that a little later. And no lexical scoping, no free variable.
So basically, your lambdas in the body, they cannot do any function calls, right? So
Sorry,
they cannot do any function calls in there inside the lambda.
No, it's nothing. You could write.
Go through the dictionary. So how would you write a function call in there? So in the body of your lambda, can you do a function call and call another lambda?
Oh yes.
Oh yeah, you do it with the squigglies. Okay.
When you see that.
Sorry, I was confused a little bit with the string substitution.
Voilà.
Yeah.
Any more questions? All right, let's thank our speaker.